Well guys, I decided I'm going to tram the mill. So in preparation of doing that, what I've done is I've rotated the turret back to 0 degrees, and I centered the table, and I've changed my collet size to accommodate this test fixture that actually was in the cabinet with the Wells Index machine when I bought it, which clearly is a fixture that somebody had made up to help them tram the mill. So basically, tramming is the principle of making sure that the head is perpendicular and square to the top of the table. By design, you're able to tilt the table this way or this way, and you're also able to do what's called nod the head. What did I say? Tilt the table, tilt the head. And you're also able to nod the head, which is, in other words, tilt it out this way or tilt it back. And so the idea is that when you're not doing an operation that requires it to be at an angle, you want it to be square to the table. Not pretty much, definitely. So how do you test for that? Well, there are a number of different methods out there on the internet and everything, but this is one method that I believe that the person who was running this mill must have used, because they went to the trouble of actually making up this test jig. So what I've got is I've got a pair of precision ground parallels that are equal in height, and you want to make sure your table's wiped down, you don't have anything on the table. And essentially I'm going to put one over here, and I'm going to swing this around, and I'm going to put the other one over here. Okay. And what I'm going to do is I'm going to bring the table up till it touches off and I get an indicator reading. Okay, so that's at 0. And you can see as I sweep back, it's dropping way down. Alright, so actually I gotta check. Maybe I didn't. I thought I put everything at 0. There is a scale on there so you can get close, and obviously you want both scales on 0. In other words, right here we've got an indicator. There's a line right there, and we want it lined up with that 0, which I'm pretty close there. And we've got another one on this side for the nod of the head, and I'm actually a little bit off on that one. Alright, so the first thing I want to check, I think, is I want to check the tilt of the head. So what I'm going to do is I'm going to look at this right here when I've got this pretty much lined up, when I have this pretty much lined up with this slot. Okay, and I'm going to 0 that again. Alright, now what I'm going to do is I'm going to swing this all the way over, and the indicator's not even touching now, so obviously the head needs to tilt back this way. Oh, that wasn't even close. Okay, I tilted the head back a little bit, so now it's actually not touching on either one. So now I need to bring this table up further, so I'm touching off again. Actually, that's right at 10,000, so I don't necessarily need to 0 it every time, as long as I know where it is. And actually, there's a little bit of a glare on the dial, so to make my life a little easier, I'm going to use the 20,000th division. Okay. And if I sweep this back, you can see it is changing a little bit. Alright, but not as much. So now I come over to this side, same proximity on the table, Alright, so I just spent about probably 10 or 15 minutes going back and forth, measuring, basically I picked a spot halfway between this wide part of the table right here, between these two T-slots, and that's the spot where I'm putting the indicator over on this parallel, and then I swing it over and look at the, put it in the same position on the other side, and look at it in the mirror, look at what the difference is, split the difference, and then come back over because it's easier for me to look at this side straight on rather than in the mirror and adjust. And I fudged that a couple times. The other thing too is I needed to tighten up the top nuts more because the top nuts were loose enough that allowed the head to actually be sagging. So the problem was that even if I was getting close, then when I would tighten the nuts, that would cause the head to tilt a little bit or move out of position a little bit. So I was within about a half a thou, and I just tightened it down. So I'm going to do my final check, and hopefully nothing really changed much. So I've re-zeroed it there. The other thing too, I put it in neutral, which is a lot easier because now I can do this, whereas I was fighting the belt, and because it's the way the belt works, it kind of was hard to get to spin around nice and freely. Now I can spin this real easily. And so just look at this, and that's dead on, still on 0. So is it trammed? Well, no. All I've proven is that the head is now perpendicular to the surface, to an imaginary line down the center of the table, or down this part of the table. So I still could have a problem with nod, and the only way to really test that would be to, well, what I could do is I could do the same test I'm doing here. The problem is I don't have a parallel. What happens is, because this swings out, this sits way out here. Same problem over there. I'd have to move the table back and forth as I did my measurements, and then I would be actually factoring in the wear and the ways on the saddle, so I don't want to do that. So theoretically, I think that now, because I've trammed it or got the tilt correct, that if the nod is off, then I'm going to see the needle change as I sweep this parallel from near the front over here to the rear. So in other words, I can bring this over, let's see, to right there, and so I could sweep right across to the rear, and I could see that that's definitely dropping down as it goes to the rear, which is simulating the table's tilted to the rear. So if that's the case, if it's acting like the table's tilted this way, then that must mean it's knotted forward. Yeah, so this is a little higher in the front than it is in the rear. That's got to be the head's knotted forward a little bit. Still looks like 2000s. Oh, wrong way. That's at 1 right there, so that should be splitting the difference. And it's not even close. What the hell's going on here? There we go. That's about a half a thou there. And it's about 1,000th there, a half thou out. I think I can live with that. Now, let's see if it stays when I tighten these down. Resetting the dial to 0. Oh, perfect. Or is it? Alright, so now if I've got the nod correct and I've got the tilt correct, If I've got all that corrected, then theoretically I should be able to sweep and along these parallels, and the dial should stay pretty much on 0. Oh, except right there where it fell off. Ooh, I almost broke my beautiful mirror. This darn thing's a little chewed up. That nut's a little chewed. Alright. I think I want to bring this up a little higher. Alright, that's 0 there. Down 2 thousandths. Shoot. It's 2 thousandths out again. Let's see if my side to side tilt is still on. So 0 right there. Should be at 0 right there. And it's not. Alright. That's why I'm quitting for tonight, because it's driving me nuts. Watch some more videos of tramming a mill. Good morning, everybody. It's another Sunday morning. Early in the morning. Snuck down here to work on this tramming of the mill again. Last night I went online and I looked at a couple of videos. I remembered that Keith Rucker had posted a video where he trams his mill, and I remembered he showed a really easy way to do it. So I found that video and looked at it again last night, only to realize, oh, well, yeah, he found the real easy way to do it if you have a cylindrical square. And for those of you who don't know what a cylindrical square is basically a metal cylinder that is very precision ground to be square, and you basically just sit that cylinder on the table, and the sides of that cylinder will be perfectly perpendicular to the table, and then he extends the quill and puts that cylinder right up against it, shines a light from the back to see if he can see any light, and does that on two sides, on the front and then on the side, and that gets him within like 1,000th. And then if he wants to really be finicky, then he puts last word indicator in and spins the last word indicator around on the tops of a couple of 1, 2, 3 blocks and looks at how far it is out. So the first part of the video wasn't very useful because I don't have a cylindrical square. The closest I ever came to getting one was at the tool store. I saw one in the weekly video that he posted, but by the time I got there it had already been sold. He only had like, I don't know, 40, 50 bucks on it, which these cylindrical squares, if they're not damaged, they can be pretty pricey. The style that Keith Rucker had was the style that has like a disc base with a vertical post that comes up that's probably about that big around, and they typically keep those in a wooden case for protection and that. And in Keith Rucker's case, knowing him, he probably had that thing given to him for free. Either that or he scored a deal on it somewhere. Anyways, I haven't been that fortunate yet, so if anybody has a cylindrical square burning a hole in their shop and they want to send it to me for free, that'd be nice. Anyways, so I was thinking about, well, that wasn't very helpful, but then at the end of the video he brought up a couple of good points, so I was glad that I did watch the video again, because I had forgotten about, he had used the last word indicator and he extended it out maybe 6 or 8 inches, and he was bringing up the very valid point that if you get a 3/4 inch or even a face mill in there that's 4 inches in diameter, the amount of error that you're measuring, the further out you're measuring error, the more pronounced any error is going to be. So you can see I'm out here probably about 10 inches from here. So any error that I'm seeing out here at 10 inches is going to be much less pronounced the closer we get to the center line of the cutter. So if I get within 1,000th out here, for my purposes, it's probably going to be perfectly fine. Hell, this table's probably got a bend to it due to wear, You know, there's probably something going on with this table. I'm sure if I do it at one end, in the middle, and the other end, I'm probably going to get, you know, 3 different values there. I might even move, if I move the table back and forth on the saddle, it might change just from wear in the machine. So I don't want to get too hung up about that. So that was one of the points that I got from his video. And he also had a little cautionary tale about that when you get that close and you're trying to get it dead nuts on, you can actually start to get into a situation where it becomes a futile effort. I forget how he said it, but essentially because it's such little movements in these adjusting nuts can cause such big swings because of the mass and the weight that's going on here. It can be, you know, you can actually start shooting yourself in the foot if you start trying to get too finicky with it. So I'm back to it this morning, and my first thought was, well, heck. The first thing he showed that, you know, you could put a regular square on the table, but he doesn't like using a regular square because it's hard to get the alignment perfect, or for whatever reason, I forgot what. I think mainly because he's got a cylindrical square. So I've got some squares I could use, and then I thought about it. I said, well, what else do I have around here that I could use? And boiler fire something. Well, I've got this wrist pin from a Detroit Diesel, and this wrist pin, oddly enough, has some of the qualities that you would expect to find in a cylindrical square. For one thing, it's recessed at the very bottom here, so only this bottom edge, when I put this on the table, only the very edge, outer edge of the pin actually contacts the table, which I've actually seen homemade cylindrical squares, and that's pretty much what they do, is they recess that. So it's got that. It's got a, well, other than the score marks on the side here from this being a very abused machine, it's got a highly polished outer surface, and it should be pretty darn square to the side, to the bottom. So essentially what I've got here is a poor man's miniature cylindrical square. So I think what I'm going to do is I'm going to pull this out, I'm going to stick this on the table, and I'm going to use this to get it in rough, and then go back and do the sweeps and check. And I also like Keith's idea of using the 1, 2, 3 blocks instead of the parallels, because parallels, I'm aiming for this little narrow track right here. The 1, 2, 3 blocks give you a little more surface to play with. So I don't know how well that's going to show up because of the glare of the light being directly behind it, but I can see that the very top edge is touching, and then there is a space in there, and you got to kind of move it just right so you can see it. And I can actually see a couple other spots that look like they're touching, and those are actually where these score lines are on the side of this pin. So unfortunately I don't think I can really use this pin to do this because of the damage on the pin. Yeah, I think I'm going to scratch that idea. Not only that, but I'm sure when this was made it was probably perfectly perpendicular, the sides to the ends, but after years of being beaten in that machine, who knows how round this pin even is. So then it occurred to me that if you have a 1, 2, 3 block that you have confidence in, that, you know, that it was, if it's a homemade one, that it was either made correctly, or if it's a shop, store-bought one, it doesn't look like it's been dropped down a flight of stairs like most of my 1, 2, 3 blocks. Well, this one doesn't look too bad, but I'll tell you, it's pretty difficult to see that gap clearly. Alright, right now it looks like it's touching at the very bottom, and there's actually a gap at the top, which would indicate it needs to go that way, just a tiny bit. Alright, so I took the best of the 1, 2, 3 blocks that I do have, and I set this and it looks like it's really good and close, and then I flipped it around over to this side using the same surface just to check to make sure, and yeah, that looks really good right there. So I locked the head down. The other thing that's kind of tricky is when you actually lock the nuts, that can just put a little bit of a torque on this thing, and because there's wear in the worm screw, and well, it's kind of like a pinion, not a pinion really. Well, anyways, the drive that actually this bolt that I'm turning actually has a worm gear that engages another gear on the back of the head, and that's how this turns. There's play in there, so you can imagine that, you know, when I go to tighten this, I'm putting a little bit of torque on this thing, and it can throw it out. So kind of a bit of a learning curve there. You kind of want to be a little bit over on one side of it so that when you tighten it down and it torques it back to the other side, it brings it right back on. But I don't see any light coming through this now, so I'm now satisfied with my side to side. I'll check it with the indicator, but I bet you I'm not going to touch it now, because I bet you it's within close enough tolerance that I'll be happy with it. Alright guys, so I got the nod straightened out too. Same principle as I used for side to side. So now I'm getting ready to sweep this indicator around the table again, but I'm going to use the 1, 2, 3 blocks instead. And before I do that, I'm going to mic these 1, 2, 3 blocks because I've never used them before or checked them. So I actually have no idea whether or not they're even correct. Lots of times when you find these 1, 2, 3 blocks at yard sales, flea markets, whatever, lots of times they'll be over 1 inch, and the reason for that is because oftentimes somebody makes a homemade pair of blocks with the intention of having them precision ground and never gets around to having that step done, because a lot of guys have the equipment to make a block but don't have a surface grinder, so they send them out, and if they never get around to it, well, but that one there is right on, as is that one within maybe 1/4 of a thousand. I guess I'll check this oddball one. I'll get this one that's not a match to anything. Oh, there you go. Case in point, this one's about 5 thousandths over, so this one never made it out to be finished up. We'll check that, but I'm pretty sure No, I was reading the wrong line on this. I'm not used to this. I just grabbed this micrometer quick. It's got extra lines on it for like a vernier. No, actually this one is also dead on, so I can use that one. So I can use 3 blocks. Well, I just swept this around, and when I zero it here and I sweep it around to the same position lined up over this center slot, it's 8 thousandths out. So much for that whole process I just did there. That was kind of a waste of time, I guess. I can get it closer than that just doing what I was doing last night. I guess I'll check the front to back while I'm at it. Alright, so I got it pretty much right on, and then of course when I tighten the nuts down, it threw it out a little bit. But that's such a small amount, I think I'm going to just live with it. The tightening of the nuts moves the head a little bit. So, okay, so I'm right at 0 to 0 right there. And again, I'm trying to line up right over the leading edge of this T-slot. The reason why I'm not doing it directly on the table is in case there are any oh, look at that, 1/1000th. 1/1000th of an inch out over this distance from here to here is going to equate to not enough for me to bother trying to get it any closer. That's going to be good enough for my purposes. So I've cinched down those bolts really tight, or the nuts really tight. So now I just got to recheck the nod, fiddle with that, and Then as soon as the family's awake and I can make the noise, maybe we'll do a test cut. Won't that be fun? Well, it took me a while, but it looks like I finally got this thing dialed in. I've got the SPI quill clamp on here. I set it up with my best test indicator, which is in half thousandths. Got a 1, 2, 3 block on the front and the back. And I basically just set this to 0 when it's on the block. So you can see it's just maybe half a thousandth. So touchy. There you go. So that's like at 0 right there. So we can zoom in on that. So some glare on there, but that little fluctuation there is just when I'm hitting a hole. You can see now I can sweep back and forth on that block, and that's not changing. And then if I come all the way back to the rear, and I'm looking at that in the mirror, and I can see that that's maybe half a division, and each one of those divisions is a half a thousandth, so I'm about a quarter of a thousandth out. So I'm real pleased with that. I just come over to this side and right on 0, and then last check is going to be to spin this around, hold the block into position, and that's actually the furthest out it gets, which is, that's 1.5 thousandths there. Yeah, 1.5 thousandths. I wonder why that is. Why would it be okay here, okay there, and out 1.5 there? Could be an imperfection, I guess, on the table. I keep going to grab the indicator to spin this, which is a mistake because then I'm gonna affect the whole. There's 1,000th now. But I can live with that.